And the three, just similarly to what we had with angles, you had three diagrams. You had outside, inside, and on, where the angles were at. When we're dealing with segments, it's kind of the same idea. But it looks a little, we're not going to use outside, inside, on because it's not the angle. We're going to use secants and tangents, and then we are also going to use the chord talk, all right? So one of the ones that we look at, or one of the first ones we have, is when you have two chords intersecting in a circle. If two chords intersect in a circle, how many segments are there? How many segments are there? 4 of them, right? So you wind up with 4 segments then. You wind up with 4 segments. And what I want to do here is just kind of label it in terms of very, very easy way. Little a, little b, little c, and little d. Okay. You need paper?
No, I need a watching.
Okay. You might also want to draw a couple of patterns. Could help. So when we do some of these things here, what I want you to think of is there are chunks on the inside of the circle. Okay? What I mean by that is there are all these little there's 4 segments. I forgot the words were called. I have 4. Bless you. We have 4 parts here. And the easiest way to write this out, the easiest thing to think of, is quite literally chunk times chunk is chunk times chunk. So it's going to be A times B equals C times D. What happens here is, if you think about it, you've got your 2 segments. The 2 segments have been cut into 4 parts. The 2 parts on one segment multiplied together equal the 2 parts of the other segment multiplied together. I'm trying to keep this as little verbiage as possible because it becomes a lot easier. If you just remember that it's piece times piece is piece times piece. Okay? Chunk times chunk is chunk times chunk. Sounds weird, but it is so much cleaner than writing all of that out. I'm hoping you would agree with me on that. Because if 2 chords intersect inside of a circle, the product of the lengths of the segments of one chord is equal to the product of the lengths of the segment of the other chord. Chunk times chunk is chunk times chunk. That's it. Okay? It is much easier. So if I'm looking at something like this, yes, I will throw something at you right away with algebra, because might as well start out with a bang. Excuse me. We have segments that are intersecting on the interior of a circle. Bless you. So if I do the same idea, it's a matter of just being able to pick out which parts go with what. Yes, ma'am?
So it doesn't matter if we do, let's say, C times D equals A plus B, it doesn't,
Not A plus.
or A times.
Nope. Because it doesn't, you can flip-flop these back and forth. As long as they're on the same part,
Okay.
fine. That's the idea. They have to be the same segments, the 2 segments that create the larger. Just as long as you keep that straight, you're going to be okay. All right. So if I do this one, I'm going to have the x plus 2 times the x plus 1 is x times the x plus 4. So, like I said, by writing this out right away into an algebra setup, well, I don't want to, not to scare you or anything, but the idea by showing the algebra right away, it's helpful to show you what's going to happen. So this means you have to FOIL. FOIL and distribute. Left side, FOIL it out, you're going to get x squared plus an x plus a 2x plus a 2. And on the other side, you distribute again, you get x squared and a 4x. So far, so good? All right. In doing that, now I combine my like terms on the one side, or can I do 2 steps at once? If you look at this, do you have x squareds on both sides?
Yep.
Are there any other coefficients with the x squareds? They're both 1, correct? So what happens to them? They cancel out. We can subtract them, they go away. I know that this is going to happen. I can go on. What's an x and a 2x? 3x. And you go back to the idea now of picking on the little guy. Who are you going to move? 3x. Move that over, what do you get? And you're done. Okay. So yes, you will see the foiling, the distributed property, all that kind of fun stuff. It does not go away. But the idea here is that you have to make sure that you distribute correctly. Okay? You got to distribute correctly and go from there. Not too bad. There's a lot of foiling in this section. A lot in this one. Let's do another one, speaking of. Excuse me. We're meeting on the inside. We're meeting on the inside, so it's going to be chunk times chunk is chunk times chunk. Quite honestly, a lot of times in these problems, people just kind of get goofy with what goes with what, as far as what, does the 3x go with one side or the other? It's easy for me to draw these things overly large that fit on the smartboard so that you know where parts go. But sometimes on books or in worksheets and stuff, it is, with a smaller diagram, they get kind of messy. A lot of times, if you're reading it, you see little arrows pointing to it. That's usually where things get goofy. Or if your answer gets to be really nasty, you probably flip-flopped apart. That's kind of a dead giveaway on some of these things. So here, 3x times the x plus 1 has to equal the x and the 4x. Distribute both sides. Okay, just like you would normally. Distribute through, we get 3x squared of 3x. And then on the other side, we have 4x squared. We okay with that? Now, we have to set aside equal to 0. Am I going to move things from the right to the left or left to the right? Left, right. Good. Subtract 3x squared and subtract 3x. You're going to get 0 is x squared minus 3x. And once again, back to a crash course in remembering how to solve quadratics. Your first rule for x squared when you have a stuff equal to 0 is to always look to see if you have a GCF. Do we have a GCF here? What does an x squared and a 3x have in common? X. So do we have a GCF? Yes. So you factor out an x. Do I have two parts now that are equal to 0? The answer is yes, which means your zeros will be x equals 0 or x minus 3 equals 0. Yeah, there's a lot of this in this section. This is where all this algebra comes back. So in doing this, first answer gives you, what is x equal to in the first one? 0. So your first answer is 0. Okay? What's x equal here? 3. So you have two possible answers, 0 and 3. Does 0 work in the circle? No, it doesn't work. 0 won't work in this example because I can't have a 0 segment. I can't have a segment that's drawn in there of value of 0. Okay. Plus, if I substitute it in, I get 0 times 0, which is 0. Here I get 0 plus 1, which is 1, and this is 0. So you're not going to get 0 seconds, so you can throw that one out. This is also an example that, remember how sometimes when you do these, you get a negative answer? This is one time that negatives could possibly work. You, oh, bless you. You always want to go back and double check everything. Bless you. And then the 3, excuse me. Obviously with the 3, we should be all right then. Yes, ma'am. When you're working with algebra, when you have an x squared minus 3x, there's no, it's not a trinomial, so there's no like x squared minus 3x plus 4 or something like that, okay? So when you have that, you have to set it equal to 0. Solving for x then means your first rule is to log GCF and set both those terms equal to 0. That's where that comes from. All right. You'll see it's a factoring problem, and there's a lot of them. Okay. What's that?
Nothing.
You complain too much.
Yeah, I got it from you.
Eh, I'll get over it. So we've done segments on the inside. These are 2 segments that meet where? On the outside. What are those 2 segments called? That's for angle stuff. I'm talking about what are these segments called when they go through a circle?
Something, it's on the,
When a segment goes through a circle, what's it called?
it's on the, that's all I know. It's a chord.
No.
Oh, damn.
Chords are interior. What is it? What is it?
Line
No, tangent touches it one spot. When it goes through it twice, what's it called? Secant. In this case here, these are both secants. Okay? There are 2 secants here. There are 2 segments that go through the circle. Now, do you agree that there's an outside part? This is an outside part, and then this is the whole thing?
Yes.
Does that make sense? You have an outside part, and then you have the whole segment? By using basic terms. So this is another out.
Wait, if you have an outside chord, does that mean you have also have an inside chord?
There is, but I don't really worry so much about the inside part here, because when I have 2 segments that are like this, the formula is outside times the whole is outside times the whole. I don't worry about I don't have to worry about saying outside times inside. I'm worried about the outside times the whole thing is the outside times the whole thing. Oops. So, do this real quick. When you see that, outside times the whole, outside times the whole. We don't need to worry about long-winded definitions. It's outside times the whole is outside times the whole. Right? Not doing long-winded things, not putting in letters and all that other stuff. This chunk times the whole thing is that other chunk times the whole thing. Notice, I'm not dealing with angles. I'm just worried about this. So, here's an example. So you have two segments that meet where? Okay, thank you. They meet at E. Very good. Is that outside the or inside the circle? So we have two segments that meet outside. So that means it's going to be outside section times the whole equals the outside section times the whole. So if I'm looking at the top segment, the EAB segment, or EB I should say, what's my outside? 4. What's the whole thing? How much? 9. Whole thing is 9. Because you add. Okay? You're adding. Equals, what's your outside? 3. What's the whole thing? 3 plus x. You're adding, guys. You're adding. The whole thing here is 9. The whole thing here is x plus 3, or 3 plus x. That is a big mistake that most people make. I'm glad you made it right away. And now you won't do it again. So, 4 times 9. Okay? And you're back to a 2-step algebra problem, just by redistributing. Going backwards with your redistributing of the algebra then, what do you do first? Subtract the 9. Subtract the 9, what do you get?
25.
And what is x? Outside times the whole equals outside times the whole. Okay. Pretty simple. Let's try another one. Actually, let me see if I think I got one in here with algebra. Yeah, let's do this one. Excuse me. All right, so again, we have the same basic diagram. You have your outside chunk times the whole thing equals the outside chunk times the whole thing. So write it out. We know it's going to be outside times the whole is outside times the whole. First segment, what's the outside? 3. The whole thing is going to be 3 plus x plus 2, otherwise known as, there we go. The outside part is x plus 1. The whole thing is going to be x plus 1 plus x minus 1. So you get the whole here, x plus 1 plus x minus 1, otherwise known as 2x. X plus 1 plus x minus 1, 2x. All right? Stuff on the left is easy. Distribute out and go. You have 3x plus 15. Other side, you wind up with squares again. 2x squared plus 2x. Thanks, Austin. Okay. What's that? You could FOIL, or what I did there is I just distributed going the other direction. That's all. Do what? No, you because the whole thing here is 3 plus x plus 2. Bless you. The whole thing here would be 3 plus x plus 2. So what's 3 plus 2? That's all. We just shortened it up. All right. So now we have to set aside equal to 0 again. Since our 2x squared is positive, move everything to the right-hand side. So I'm going to get 0 is 2x squared minus x minus 15. Oh boy, we have to factor again. So, yep, told you guys, it's all coming back in this section. All comes back. Now, I go back to the old school method of multiply your tails to add to the middle. Because I've always found that to be, if you know your times tables, you're gonna be fine. So what's 2 times negative 15? I'm multiplying my tails together and I get negative 30. What are your multiples? What times what is negative 30, but it adds to equal negative
5
1?
and 6.
It's a combo of 5 and 6.
So that'd be negative 6 and 5.
Right. Since the middle term is negative, that means the larger of these two numbers has to be negative. So you get negative 6 times positive 5. So what I do then, let me move this up here. What I do now is that I rewrite this as 4 parts, okay? Split the middle, however you want to call that. So I go 2x squared minus 6x plus 5x minus 15 is 0. I group. I call it's split the middle, factor by grouping, whatever you want to call it. Because now what I'm going to do is take a GCF twice. When I have 4 parts written out, I take the GCF of this. What's the GCF of 2x squared and the 6x? What do they have in common? 2x. Then you're left with that. What does the 5x and the 15 have in common? 5. I take out a 5. I'm left with this. Now, are my 2 parts that are in parentheses the same?
Yes.
When that happens, you write it down. And what's left? Well, no, what's left in here? Part. I have 2x and a 5. And now you finally have factored something to get to the point where you have 2 terms that you can set equal to 0. And that gives you 2 possible zeros. First one's easy. It's 3. The second one you have to do 2 parts. Subtract 5 and divide by 2. Negative 5 halves. Okay. I hate to be the bearer of bad news, ladies and gentlemen, but everything that you thought you got rid of in algebra about factoring and toiling, it's all back today. It's in this section over and over and over and over and over again. Okay. And it,
There's no shortcut.
you can guess and check if you know your terms, but there's really no shortcut. Okay. So going back up to here, we had possible answers at 3 and negative 5 over 2. Negative 5 over 2 is negative 2.5, right?
No.
If I put negative 2.5 in there, am I going to get positives or negative segments? So what do I do with it? Throw it out. And I really only have to worry about my positive answer in this case. Yeah, there's no shortcuts to this one, unfortunately. Even still, there are a lot, I mean, bless you. In Algebra 2, you could use synthetic division to get to some zeros a little bit quicker, but you have to still go through your possible factors to get to it, to be able to pick those out. Oh, synthetic division, you're so much fun, okay? Remember, it's not that the geometry concept's gonna be all that crazy. It's that you guys all have to know that you've taken an algebra class and you are kind of expected that you know how to factor and FOIL.
Wait, I forgot how to factor in the FOIL.
Well, it's also that same idea that you're kind of expected to know how to add, subtract, multiply, and divide by now too.
Well, that was easy.
Sucks to be USD.
Austin? Don't. Okay? And then the last one. The last setup. The last one.
Why don't you just ask us to find the angle?
What's that?
Why don't you just ask us to find the angle?
Because that's only half of it. You still have segments and angles. Because aren't angles made up of segments? Okay. All right. So in this case here, you have one segment that goes through the circle, and one segment that touches the circle at one spot. When you have a segment that touches the circle at one spot, what is that segment called? That's tangent, right? So you have basically a tangent and a secant here. So you have the tangent segment is this. There's your tangent segment, and this is your secant segment.
What is the formula for tangent segment?
We're getting there. All right. But here, chunk times chunk is chunk times chunk inside. This one, you had two secants, basically. Outside times whole, outside times whole. Here's the last one. Now, if one of those is a secant segment, what did I do for both of these secant segments?
Outside times whole.
Out times the whole. What do you think I'm going to do here?
Do the same thing.
Okay, one of them is going to be outside times the whole for that secant part. So what this one is just the tangent one squared is outside whole. So you just have to understand, you just have to figure out which one is the tangent segment, excuse me. Which one of those is the tangent segment? The top one. The one that touches the circle at one spot. So you just square that segment outside times whole. Here's your tangent. Here's your out. And here's the whole. Okay. And that's the last one of these. Tangent squared, out, whole.
So if it was to tangent, it's probably tangent squared equals to tangent squared.
Yeah, but we don't deal with we don't usually deal with those because remember, if there were two tangents meeting at the same point, those segments are always equal from way back when.
When was that?
A couple weeks ago. Anytime that two segments that are tangent meet on the outside of a circle, those segments are always congruent. So if I did tangent squared equals tangent squared, isn't that the same thing as tangent equals tangent? So you're not wrong. Just making it easy for you. So let's look at an example. Excuse me. So you have we have an outside and a whole thing here. Oh, one second. We have an outside and a whole, and we have a tangent. Which one of those is the tangent segment? Yeah, the x. So the x is your tangent segment. So you have tangent segment squared is the out times the whole. So you write it out as x squared equals 1 times what? 4. All right, deep breath. 1 times 4.
Oh, gosh.
How do you solve for x?
Square root.
Square root it. Now be careful. When you square root something, technically isn't it a plus or minus when you go over an equal sign? Because is it -2 times -2, 4? So my answer should be x equals plus or minus 2. But can I have the -2 as a segment line? No. In this case, I cannot. So my answer is just going to be positive 2. It would be wrong because -2. Can you walk a segment length of -2?
No, but one forgot, there was a chapter, but one forgot to.
I would suggest that you don't forget that because now you're going to hate me for this one. Sometimes the negative answer works.
I
So
already
do you always double check? Always double check your negatives. just like I did here, I know I can't have it, but let's say this was, for fun, I don't know if this would work, let's say this was x plus 3. Is negative 2 plus 3 a positive number?
No. Wait, yes, it is. Negative 2 plus, oh, no.
See what I'm saying? So in that case, you could get something to work. All right, I'm just kind of forewarning you that it could happen. Okay. All right, let's try another one.
Hey, CJ McCollum in the offense.
Hold that.
We might be facing
It's early.
pretty soon. We might be facing
Very early. So example here, we've got that tangent segment, and then we have an outside and a hole. So I start by writing it out. I know it's giving my tangent segment squared is outside times the hole. Which one of those is your tangent segment? 12. So I write 12 squared. What's my outside?
X.
And what's the whole thing? Good. Which means, again, I'm going to have to distribute and set aside equal to 0. 12 squared is 144.
You're saying whenever there's an X where you have the 7 0.
Yeah.
Nothing else. It's on the X or the square.
Well, you still have to solve. Basically, you're solving for x. And the previous example, it was just x squared equals 4, so that way you didn't have to do much work on that one. But this one, you wind up with trinomial. So I have to move that 144, again, by setting it equal to 0. How do you move a positive? So now I have to figure out what times what is your negative 144. What it adds together to give you a positive 10. Now, here's a way that you can kind of guess and check your way through it. Obviously, you guys have calculators, so that's helpful. In this one, I know it's 12 times 12. I know that gets me there. One of them's positive, one of them's negative. But if I add those together, I would get 0. So what I want to do is think about numbers close to 12, something that might work.
62.
But 6 times 2 doesn't give me 144. Okay. So what I want to do is think of it. I take my calculator out and I try 8. I try an even number around 12. I know that 10 doesn't go into 144 because it doesn't add into 0.
But 9 does.
9 would work. Or try 8. Try a number in that realm, something close to it. What is 144 divided by 8?
18 and 8.
What is it?
18.
It's at 18? So I have 8 and an 18. If I use a combination of those two, do I get a 10? Which one becomes negative then? The 8, good. So this becomes a negative 8. Now, here's the trick. In this case, since my first term is 1 for a coefficient, I don't have to do that factor by grouping, because that's an extra step. Here's when you can just go x minus 8, x plus 18. What are your two possible zeros then? Positive 8 and negative 18. Which one of those do I have to throw out? Negative 18. Because I can't have a negative segment one. Factoring, foiling. Foiling, factoring. It does not go away.
Okay, so it's a 1.4 and 10. Remember doing that?
Yeah.
So like, find what equals 10 and 1.
There's so many different ways of doing it. I always go back to this method of just
Yeah, because I remember doing that.
Just always think of what times what is your tails that add to the middle.
So we just do either one of those sides, or just do the opposite. Like this,
Yeah, you're trying to figure out what are your multiples of 144 that add together to 10. So you know 12 and 12 won't work. So So what I'm doing, I just guessed. I knew if I went to, I know 10, I was thinking even numbers. So I knew I wasn't gonna bother with 11, so and I knew I can't go 10 times something won't work because there's no 0 in it. So I go to the next even number of 8. I was just guessing. 8 might not have worked, it could have been 9, I don't know. That's why we just guess. You guess the numbers are around that area. Yeah. Times the end, adds to the middle.
Can you like, list down like 1 through whatever, like?
Yeah, you can do it that way. It's longer, but
Yeah.
this is a little bit of that good old-fashioned guessing check. Let's try another one. I want to make sure I show you one like this because this is another example that most people mess up. Yes, ma'am. Okay. It's another example that a lot of people mess up on.
Tell a good lie.
So again, we have a tangent segment and an outside and a hole. We have a tangent segment and an outside and a hole. So algebraically, again, we have to make sure that we write this out correctly. Which one of these is the tangent segment? The x plus 4. So algebraically then, we have to know that it's going to be the quantity x plus 4 squared is your outside, which is x, and your hole is x plus 12. So now when you see junk squared, what does that mean? Junk times junk, very good, FOIL it. You cannot just distribute, you have to do this. And I guarantee a third of you will screw that up. All right, you have to FOIL that out. You get your x squared, 8x, minus 16 is x squared plus 12x. Factoring and foiling does not go away. You guys have to make sure that you remember junk squared is junk times junk.
First, outside, inside, back.
Yep. Yeah, what I did there is I kind of shortcutted it because I remembered the pattern. All right. What's going to happen with your x squareds on both sides? They cancel out. This one's not so bad then. Those go away, and now you just have to pick on the little guy. Who are you going to move? 8. So I move the 8x over, I get 16 is 4x. What do you get for x? 4. Okay. Let me give you a handful of these to try out for tonight. I know, aren't I? I'm the hostess with the mostest. I know it doesn't. But that's cool.
I think you use it. So perfectly structured.
Try those out. Excuse me. All right.
It's like literally like the worst.
Oh.
Besides like walking meters.
Guys, actually, sorry. Forgot the other one wasn't mixed into it. Let me change that. Sorry. It's the same number of problems. I just backed it up a couple. 3 through 15. Sorry, not 6 through 18. 3 through 15. Bless you. All right. 3 through 15 on those. I'll post it on the calendar here in a second as well. All right. Make sure you guys, hey guys, heads up here. When you're doing your work, I would highly suggest on the top of your page, write down those 3 little quick things. Put it in the top margin of the page, that way it's right there as you're doing your work, you know what formula to use.
But isn't that cheating, Mr. Murphy?
Oh, stop it, it's called making your life easier. You know? Try.
I didn't take a bro. I did.
Yep, yep.